Welcome back, guys. So now, since we got the hang of how to solve first order linear differential equation with initial value problems, we're going to get straight to it. Just solve the examples and show how to do the solution. The formulas and whatever that was mentioned for first order IDE with the integrating factor is not listed here because it's been done in the previous video. So if you want the formulas, you can always go back to the previous videos. So we're just going to solve this equation, and right off the bat we have to look at, oh, can I make this into the format for in a linear first order linear differential equation? First of all, it is a first order, right? Which has a power of 1. Second, how are we going to make this into the format? Well, I could just divide this whole thing by x, so this becomes y prime plus 2 over x y equals 4x. Okay, cool. Now this is our actual question, that's our new question that's going to be given. So we're going to go straight off and find the integrating factor. So to find the integrating factor, just e to the power of whatever this function is, which was p of x, right? So just to make things clear, continue solving it. Okay, so this what is e to the power of 2 ln x, okay, which is the same thing saying as e to the power ln x squared now, which is like saying okay, here. Okay, so this is our integration factor, the x squared. Second, we are going to multiply this integrating factor across this whole thing. So I'm just going to do that really quickly. Okay, so now since we solved this whole equation, I just distributed the integrating factor across our new equation. So x squared y plus x squared times 2 over xy equals 4x squared and x cubed, okay? And then if I make that a lot more clear, I simplify it to this. Okay, so now what we're supposed to do is integrate. We have to integrate both sides, right? So I have to integrate this side and I have to integrate this side. So to make things easier, whatever formula that I showed you earlier, all we're going to do is use the integrating factor times y equals our q of x, 4x, times our integration factor. Okay, and then only take the integration of this side. Okay, now when we take the integration of this side, it's fairly straightforward, and plus some constant. Okay, these stay as x squared y, and let's just keep it x squared y equals x to the power 4 plus c. So to isolate y, y is equal to x to the power 4 plus c over x squared, which finally is x squared plus c x to the power negative 2. Okay, but we are not done the question. This is an initial value problem, just as we've seen up here. So this is an initial value problem with y of 5 when x equals 5, y is equal to 2. So when x equals 5, y is equal to 2. So we can say y is equal to 2. And then x equals 5 plus c, 5, negative 2. And then we solve for c. There you have it. You have your constant c, which is equal to negative 575, and finally we get our final equation. We just plug c back in. It's x squared plus actually we'll just put the negative, x squared minus 575 x to the power of negative 2. And that, my friends, is the final solution to your initial value problem of the first order linear differential equation.